There we go. So identify what A and B are. So here's A, B. So this is 5.2, number one. So add them together because this right here is basically the third formula right there. So what is 112 plus 38? And that's what, at 150? So is 150 on the circle? Yeah, that's the goal, right? We want to combine them to something simple, and then hopefully it's on the circle. That's the goal. So that's what they do right here. Check it out. It's not really much work to do. It's like, all right, we'll add them together, 150, and the unit circle is going to tell you, well, that's going to be this. The x value at 150 is negative root 3 over 2. Nothing else to do. Do you see what we're doing and why we're doing it? We're applying the formulas. We're basically you need to identify that this is a product, and we're going to a sum, right? The sum and difference of I'm sorry, the sum and difference of angles. We're applying them here. So we identified it was a third one right here, and then we used it. That's pretty much it. Okay. So not really much to do. And this section is actually really short, so that's kind of cool. It's like five problems. So this one is the same deal, but this is the sum and difference of tangent. So we'll do this on paper. Just maybe, let's see. So can you tell which formula we should use? Right, that's really all the main thing that you need to be able to tell. And it's not the first four. Plus, plus, minus, minus. So it has to be this guy, right? It matches perfectly. My A is 4/7 pi. Oops, 4 pi x 7, sorry. My beautiful handwriting. Or went to the doctor and I got a prescription and it looked exactly like my handwriting. I was like, when did I write this? I was like, well, no, I write just as bad as my doctor. I see what's going on. It's horrible. Legit thought it was me that wrote it. Like, what the hell? All right, so here are my two angles. All right, so we're just gonna add them together and combine it into this. So all of this turns into tangent of A plus B, and the A and B are down there. So the idea is super easy, right? It's just that we have to add fractions again, and that's annoying. But you see how the main idea is pretty straightforward. Is there any questions on what we're doing? Okay. So let's go and look at it. And we can do it by hand if this is not clear, just let me know. So notice how they skipped the fraction step right there. This needed a 3, so they multiplied top and bottom by 3 and made it into a 21. That's pretty much all they did. They just took the 4 sevenths pi, 4 pi sevenths. So I'm dyslexic. Forgive me. 4 pi over 7. So multiplying gives me the LCD that I want. So 4 times 3, 3 times 7, 12 and 21 are different, right? All right, so there it is. So that's how they get this guy. They just multiplied by the 3 over 3. So now that they have the same denominator, 12 pi plus 2 pi is 14, right? So at that point, you reduce it. So once you add them, you get this guy, and then you reduce. So what are they both divisible by?
7.
Well, divisible by 7. So 14 divided by 7 is 2. 21 divided by 7 is 3, which gets us to here. Now we have to find the circle, right? Sine over cosine at this angle is going to be 2.
Mm.
What is that? What's 2 pi thirds again?
120.
120.
So then
So,
it'd be um 32 over a half.
oh yeah, it is negative. I was like, where's the negative at? Okay. So we're going to get, it's y over x. So it's going to be square root of 3
Over
over
2
2 divided by
negative.
1 half. The negative is the x. Yeah, you're right. So then these cancel. And the reason they cancel, in case you forgot the fractions,
Square root of no.
right? So there's my exact answer. Oh, so they get this. So they use the circle, but first they add the angles using the fifth formula. Then they reduce it. And then they find it on the circle. That's it. The same thing as the last example is just that the tangent is a little bit harder, but it's the same thing. Any questions on this guy? That okay, or do you want to see more details, or I'm assuming it's okay. If you want to do it all on paper on this one, we can, if it wasn't clear. All right, I'm assuming you guys are good then. Let's see what the next one is. Um,
I got us, all we gotta do is stick this in the microwave. Just feed me this.
Mm.
I had some sausage. I didn't buy enough bread. So I'm gonna put some in the fridge until tomorrow until I get more bread.
Mm.
okay. This one's a little, well, we kind of did stuff like this towards the end of Unit 1, I think. It's just now it's more strange. Um, so basically, we're gonna have to deal with this triangle stuff, do this in general,
Mm.
apply the formula. So it looks harder than it is. I mean, it looks terrible, but um, the first thing you gotta do is apply the difference formula. Because check it out, you got a minus, right? So apply that first. So let's do this on paper because there's a lot of moving pieces.
What'd you drop in there?
See, Number was this? Oh, three. Three. So write the trig expression as an algebraic expression in U and V. Go. I need to find the formulas. I think I have the PDF somewhere. One sec. Excuse me. Oh, there it is. They have it in the problem. So sine of, I think we used A, right? Sine B. Go. So use this. I mean, this is not given to you, but this is what we're going to use. Okay. So here's the question. Sine of cosine inverse of U minus sine inverse of V. Okay. So this is my A and B. Okay. These two thingamajigs. Now we're gonna have to build two triangles in order to solve it, but I'm gonna set it up first before we get there. So sine of cosine inverse of U minus sine inverse of B is equal to sine of cosine inverse U times cosine of B sine inverse V. Should have figured why this homework was short. It's going to be had a couple of mean problems in there. Cosine A. There we go. Sine inverse of what was it? Sine V, right? Yeah. Oh wait, this should be regular sine. All right, so I put brackets. Those are the things inside the sine. Or I was trying to make it neater, as neat as possible. But whatever. Now, it looks like some of this garbage will cancel, right? Do you see the second part here? What do you notice?
One is an inverse of the other, which then just equals one.
Yeah, it'll equal one, but it'll equal whatever's in here, basically. These undo each other, for sure.
Yeah.
So we'll just be left with the arguments. So we're just gonna deal with this part. This cannot be solved without those triangles from the inverse section. But it looks a little prettier, right? It's a little bit. Okay, so I can't do anything else until I solve this nonsense. So what we're gonna do, so let alpha equal to cosine inverse of u and beta equal to sine inverse v. So using this and the definition, we can build our triangle. So suppose this is true, then that means that there exists a cosine alpha that's equal to u. There exists a sine beta that's equal to v. To build your triangles. I have to do the work elsewhere, but it's all good. So cosine is equal to what? In terms of triangles.
Is it adjacent over hypothesis? Yes.
You said adjacent, my bad.
Yeah.
So now just solve that missing side and we're good. What about sine?
Uh, shoot, what is it? Opposite over hypothesis.
Okay, so now just find the missing part and we'll be good. Um, okay, so we'll let A be this U, where you need B. C is clearly 1. So B will equal 1 minus U squared, which means that B is equal to the square root of 1 minus U squared. Once you square root both sides, you're going to get this. I skipped a minor step there. I didn't square root both sides. I just skipped to here. Okay, this is a U, by the way. All right, so same thing here. This will be U or V. So skipping to what we need is basically the same deal. So now that we've solved the triangle, we can go back and plug in those pieces. So what is sine in terms of U and what is cosine in terms of V, and we'll be good. But I'm out of space, so no. We had, I forgot what it was. Sine, cosine. So this will be square root. The sine will be opposite over the U. Sine of U would be oh, I already relabeled this. Throwing myself off. Sine alpha, pairing those triangles is going to be opposite over hypotenuse, so 1 minus U squared times 1 minus V squared. There we go. Back to the top here. I said let this inner part be alpha and beta here. And then by definition, the inverses are defined so you can rewrite them this way. Once I did, I can build the triangles to solve for the other sides. Once I have all three sides, then we can find whatever trig function we want, right? This is why we did this. So then we can find the cosine alpha times cosine beta minus uv, which is going to be this because they wanted everything in terms of u's and v's. Because alpha and beta was something that we just was like kind of like a dummy variable, sort of. Anyway, very similar to the question we did before when we had to build the triangle for general terms. It's just that we had to do a sum and difference first. That was the only new thing in this question. And then we had to do two triangles instead of one. So that was a little annoying, but it's we've done everything already before except that initial step. Okay. Like it should seem a little familiar, at least I hope. Any questions on this example here?
What if beta or Bravo was tangent to the power of -1 v.
Feels like cosine of tangent or something like that.
Sine of cosine minus a tangent item.
Sine of 10 inverse of like u or
Yep.
v.
Yeah.
So it'd be everything would be the same, except on this step, you would let theta equal tan inverse of whatever the
Yeah.
hell it was, and then build a triangle based on that, and use a definition of tangent instead of because here we use sine to build this.
Mm-hmm.
You would use the definition of tangent, the TOA, right?
Okay.
So you would build it that way, and then you would fill this out. And you'd end up in the same kind of spot here, and you would just substitute what is the tan of beta here.
Okay.
Does that make sense? Or
Yeah.
okay. Wait, let me write down the next one. 1 second. Okay. So we're back to proving identities. So all the previous identities are in play. Only difference now is we have some indifferences to also use. Um, and since that's the section, of course, they want us to use it. So the big hint, right? There's a sum of angles right there, so we should probably start on the left. Okay. So use the sum and difference. Cosine A plus B we set is equal to so is my A and B going to be sine A, which is X in this case, cosine Y plus cosine X times sine Y. So right here we did sum and difference identity. Okay, so at this point, I'm not sure what else to do, but we could separate the fractions and see what happens. Um, so it looks like this could cancel like this. Right? these are gone. These are gone. So I'm left with sine x over cosine x plus sine y over cosine y, which is tan x plus tan y. So here we separated the fractions. Did some algebra, then did the quotient. But yeah, that's what we wanted to show, right? Okay. Well, that's pretty much it for the section. The main thing is, let me open is be comfortable with using the formulas with actual angles, like on the circle, and then um, do that weird triangle thing and do a proof like this. Okay. That's pretty much all the problems in this section. I think the triangle might be the hardest one in 5.2.